So here we take the equation of straight line, which will be the normal line to the circle, is Lx plus my plus n equal to 0, which we mark as equation 1. Now we take the equation of circle given. So equation of circle, the given equation of circle is x square plus y square plus 2gx plus 2fy plus c equal to 0, and which we take as equation 2. Now here we have to find the condition when line Lx plus my plus n equal to 0 is normal to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. Now here if we deal with this equation of circle and then we try to find out the normal at a particular point and then we compare this two equations, that is because if we find the normal equation to this circle and this line should be identical. But the problem is that this will be a bit difficult calculation. Lengthy calculation, not difficult. This will be a bit lengthy calculation. So what we will do? We will try to shift the origin at the center of the circle. Then it will be reduced to a very simple format. So let us see what we will do. At first, we rewrite this equation of circle in a defined form. So equation of circle we write as x plus g whole square plus y plus f whole square equal to g square plus f square minus c. That is, here we have a square, we have 2ab, just we need b square, so I have added b square on the right hand side. Similarly, if we take this one as a square, this as 2ab, we need b square, we have added b square on the right hand side, minus c because c has been taken on the right hand side. Now we are shifting the origin. We are shifting the origin. We will be shifting the origin at the point at the center of the circle, and then we take the new variable u equal to x plus g and v equal to y plus a. So the equation of circle, becomes or reduces to u square plus v square equal to g square plus f square minus c. Now this we mark as equation 3. Now similarly, when the origin was shifted to any other point, that is at the center of the circle, then obviously the equation of this line will also change. So equation of the line reduces to LU plus MV equal to LG plus MF minus N, which we mark as equation 4. Now we take here a point of contact because we got the equation circle, we got the line also, which should be normal. So at first we try to find the equation normal to the circle. So for that we need a point of contact. So we take here point of contact on the circle as some P(u1, V1). Now to get the equation normal to the circle, we need the slope of the normal. So at first we find the slope of the tangent at the point of contact. Now we know slope of the tangent at the point of contact equal to slope of the curve at a point of point. So on differentiating equation 3, on differentiating equation 3, we get 2u plus 2v dv of u equal to 0. From this we get dv of u equal to minus u by v. So this is the differentiation of the curve. Now we need the slope at the point of u1, v1. So from here we can say that ddu of v at u1, v1, which is the point of contact, will be equal to minus u1 by v1. And therefore, slope of the normal equal to minus 1 by ddu of v at u1 v1. Now this gives us v1 by u1. Now after we have got the slope of the normal, we can find the equation of normal. Now equation of normal is given by v minus v1 equal to slope v1 by u1 into u minus u1. Now this we simplify and we get here u v1 minus v u1 equal to 0. And this we mark as equation 5. Now equation 4 and equation 5 should represent the same line. That is, we can say here that since equation 4 and 5, equation 4 and 5 represent the same line, so as line represented by equation 5 passes through origin, which is the center of the circle after shifting. Therefore, line represented by equation 4 should also pass through origin. Which we have got after shifting. And therefore, LG plus MF minus N equal to 0. Because if a line passes through the origin, then the y-intercept should be equal to 0. Here, y-intercept for the line given by equation 4 is this one. So that should be equal to 0, which is the required condition. Now, if we represent this in the Cartesian plane, then also you can understand that this will be the condition. Even from MCQ point of view also, if we represent the Cartesian plane, then we can just get the result without doing the calculation even. That is, if we take the circle, this one, which we think it as the equation of the circle as u square plus v square equal to g square plus f square minus c. We take this point as P, which is the point of contact u1, v1. Now here if we draw the normal, this must pass through the center of the circle because this is a tangent. Now here the normal line is actually representing what? Radius. Now radius will pass to the center. So that means that this line which will be getting normal line, its y-intercept should be 0. So from there only by diagram also for MCQ point of view, you can easily say here the line LU plus MV equal to LG plus MF minus n should pass to origin. Should pass to center of the circle, which is the origin here, and therefore LG plus MF minus n equal to 0, which is the required condition. Now here it is given that our line Lx plus My plus n will be normal to the ellipse. So equation of the line given is Lx plus My plus n equal to 0, which we mark as equation 1. Equation of ellipse given is x square by a square plus y square by b square equal to 1. So definitely center will be at the origin. So if we represent this, we get this is the Cartesian plane. So it's x prime, y prime, and we take here the ellipse. This is the ellipse we consider. This point is a comma 0. This is a prime, which is minus a comma 0, end point of the major axis. This is the end point of the minor axis, which is 0 comma b, and this is 0 comma minus b. So to get the equation of normal at a point x1, y1, which will take as a point of contact, x1, y1, we take as a point of contact. Is let p x1, y1 be the point of contact. Be the point of contact. So it must satisfy the equation. So it must satisfy the equation of ellipse. So we must have x1 square by a square plus y1 square by b square equals to 1, which we mark as equation 3. Now, to get the equation normal, because we will find the equation normal and then we can compare this equation. At first, we will try to find the equation of tangent. Now, if we get the equation of tangent, we know normal line is perpendicular to tangent. And we can find the slope of the tangent very easily because we know the slope of the tangent at the point P. Slope of tangent at P x1 y1 equal to slope of the curve at P x1 y1. So for that, at first we will differentiate equation 1. So on differentiating equation 2, on differentiating equation 2, we get ddx of y equal to minus b square x by a square 1. Now we are trying to find a slope at the point p x1 y1. So we can say here, therefore ddx of y at x1 y1 at x1 y1, which will be minus b square x1 by a square y1, and therefore equals slope of normal line equal to minus 1 by ddx of y at x1 y1. Now on simplification, we get this one as a square y1 by b square x1. Once we have got the slope, we can find the equation of normal. So equation of equation of normal line will be y minus y1 equal to slope into x minus x1. Now this one simplification will give us b square x1y a square y1x equal to b square minus a square into x1 y1. Now this we mark as equation 4. We had here equation 1, which was the equation of line, equation 2, the equation of the ellipse, and this was the condition because the point P has satisfied this equation. Now we can compare now equation 1 and equation 4 because they will represent the same line. Equation 1 and 4 represent the identical line. So we can compare and we can write a square y1 by L equal to b square x1 by m equal to x1 y1 into b square minus a square by m. Now, if we equate these two, we can get the value of x1. So from this, we can get that x1 equal to and y1 we can get as b square n by b square minus a square into m. Now, after we have got x1, y1, we can use equation 3 and we can find the required condition. From equation 3, we can say here that a to the power of 4 n square by b square minus a square whole square into L square into 1 by a square plus b to the power of 4 m square to the 4 n square by b square minus a square whole square into m square into 1 by b square equal to 1. And we can rearrange this and we can write a square by L square plus b square by m square equal to a square minus b square whole square by n square. B square minus a square whole square and a square minus b square whole square is same thing. So I have written it in the form of a square minus b square. As here also we have a square by L square. So just to make a symmetry, I have written a square minus b square whole square. Here given equation of hyperbola. Equation of hyperbola is x square by a square minus y square by b square equals to 1. We take it as equation 1. It can be simplified further and can be written as b square x square minus a square y square equal to a square b square, which we take as equation 2. Now, for finding the normal to this hyperbola, we have to take a point of contact first. If we just try to represent this graph in the Cartesian plane, just for our understanding, is here we have y-axis, here we have x-axis. So x prime, x, y prime, y. So here we take the hyperbola. Just we are representing for our understanding purpose. Now, Here what we do? Here we take a point of contact P, which we take as x1, y1. So point of contact P, x1, y1. So it will satisfy the equation of curve. Equation of the curve means equation of hyperbola. So what we have? Equation of hyperbola. So ultimately we get here b square x1 square minus a square y1 square equal to a square b square. And this we take as equation 3. Now we have to draw here normal line. So for getting normal line, at first we try to get a tangent line. Basically, we are drawing this tangent line to get the slope of this tangent at this point. And we know that slope of the curve at this point will be same as slope of the tangent line at this point. So to get the slope, we have to differentiate this curve. So on differentiating equation 1, better to think that we are differentiating the upper part. On differentiating the upper part of the curve represented by equation 1, we get ddx of y equal to b square x by a square 1. Now, slope at the point of contact is x at x1, y1. It will be b square x1 by a square y1. So this is what we get the slope of the tangent at this point of contact. Now our intention to get the slope of the normal. So if we take here a normal line, at the point P, so just to shift the point P, otherwise it will not be visible. So this is the point P. So here is a normal line has been drawn. So we can find here slope of the normal line. Now slope of the normal line equal to minus 1 by ddx of y at the point of contact x1, y1. Now, whenever we are doing this, we are thinking this one that the slope which we have got here for the tangent at this point is a finite quantity, non-zero finite quantity. This is an assumption that is a non-zero finite quantity. Since it's a non-zero finite quantity, we are assuming, therefore we can say the slope of the normal equal to minus 1 by ddx of y at x1, y. So this gives us that this will be minus a square y1 by b square x. Now we find the equation of the normal line which we have drawn. So equation of normal line at the point of contact P x1 y1 is given by y minus y1 equal to minus a square y1 by p square x1 into x minus x1. And from this one simplification we get xy1 a square plus yx1 b square equal to a square plus b square into x1 y1, which we have got on simplifying the above equation. Now we take this equation as equation 4. Now equation of the line given. Now equation of given line, which is acting as a normal to this hyperbola, is Lx plus m1 equal to 1, which we take as equation 5. Since they are identical line, equation 4 and equation 5 are representing the identical line. So on comparing them, we get comparing equation 4 and 5. We get y1 a square by l equal to x1 b square by m equal to a square plus b square into x1 y1 by 1. So we are just writing this one only. Now from this we can say that x1 equal to a square by l into a square plus b square, y1 equal to b square by m into a square plus b square. Now point x1 comma y1 satisfies equation 1, satisfies equation 1. So on substituting what we get here a square by l square into a square plus b square whole square minus b square by m square into a square plus b square whole square equal to 1. Now from this we can write a square by l square minus b square by m square equal to a square plus b square whole square. Now this is the required condition. Equation of the curve given is a parabola. Equation of the curve here parabola is y square equal to 4x, which we mark as equation 1. Now point of contact p x1 y1, p just for denoting it as a point. So since the point of contact, so it will satisfy equation 1, that is y1 square equal to 4ax1. We mark it as 2. Now on differentiating equation 1, 2y dx of y equals to 4a. So ddx of y equal to 2a by y. Now therefore ddx of y at x1 y1 equal to 2a by y1. So this is basically the slope of the tangent which we have got at the point of contact. Now we need what? We need the slope of the normal. Therefore slope of the normal minus y1 by 2a, because it is basically minus 1 by dx of y at that point of contact. So we got minus 1 by 2a. Now we can find the equation of normal. So equation of normal is y minus y1 equal to slope into x minus x1. We know y minus 1 equal to m into x minus x1. So just we have substituted the value. Now if we simplify this gives us 2ay minus 2ay1 equal to minus of xy1 plus x1y1, which on further simplification gives us xy1 plus 2ay equal to y1 common x1 plus 2a. Now, after we have got this, we can compare with the given equation. This is the equation of the normal which we have got. We can mark this as equation 3. Now, equation the given line. Equation of given line is Lx plus my equal to 1, which we can take as equation 4. Now, if we compare 3 and 4, we get on comparing equation 3 and 4, we get y1 by L equal to 2a by m equal to y1 into x1 plus 2a by 1. So from this we can get y1 equal to 2a L by m. Now this gives y1 by L equal to x1 y1 plus 2a y1. And from this we can say x1 plus 2a equal to 1 by L. And from this x1 equal to 1 by L minus 2. Now x1 and y1 must satisfy the equation of the curve. Point x1, y1 satisfies equation of curve. Equation 1. So we can write y1 square equal to 4ax1. Now from that 2al by m whole square equal to 4a into 1 by L minus 2a. Now if we simplify this, minus m square plus 2a L m square equal to 0. A L cube plus 2a L m square equal to m square. Equation the hyperbola. Equation of the hyperbola. X square by 9 minus y square by 4 equal to 1. We take it as equation 1. Equation of the line, which is normal. So equation of the line given, which is normal, Lx plus my equal to 1. So to get the normal from this curve, we have to get a point of contact. So we take a point of contact here. That is point of contact P x1 y1. It will satisfy equation 1. So we get x1 square by 9 minus y1 square by 4 equal to 1. We mark it equation 3. Now to get the normal, we need the slope of the normal. So we differentiate first to get the equation of slope of the tangent first. Because we know slope of the tangent at the point of contact equals slope of the curve at the point of contact. So on differentiating on differentiating equation 1, we get ddx of y equal to 4x by 9. Therefore, ddx of y at x1, y1 equal to 4x1 by 9y. That is the slope of the tangent. Therefore, slope of the normal equal to minus 1 by ddx of y at x1, y1. So that is minus 9y1 by 4x1. Now, once we have got the slope of the normal, we can find the equation of normal. So equation of normal line will be given by y minus y1 equal to minus 9y1 by 4x1 into x minus x1. Now this gives us 4x1y plus 9y1x equals to 13x1y1. Now this is equation 4. Now we compare with the given equation, that is equation 2 and equation 4. So on comparing equation 2 and 4, we get 9y1 by L equal to 4x1 by M equal to 13x1 y1 by 1. From this, on comparing these two, we get x1. From these two, we get y1. So we get here x1 equal to 9 by 13n, and y1 we get 4 by 13m. Now we know that x1, y1 will satisfy the given equation, that is from equation 3. So putting the value of x1 and y1 in equation 3, 81 by 9 into 169 is minus 16 by 4 into 169 m square equal to 1. And from this we get 9 by L square minus 4 by m square equal to 169, which is the required condition.